Okay, so now let's look at 2b. So here's what we have. It's multiplication. So first step is to factor everything that you can factor. So the top of this one's okay. There's nothing we can do, so that just stays x. Here, we can take out a greatest common factor, which would be 3x. And if you divide that out, then you're left with x minus 3 times x minus 3 here. We can't take anything out. I'm going to go ahead and put that in parentheses. And then here, notice you have a trinomial. Now we have a 2 in front of the x squared, so we can't just do our shortcut. So then down below here, I'm going to do my AC method, where I have the 2x squared and then the minus 3 at the end. So multiply those. So 2 times negative 3 is negative 6. So what multiplies to give you negative 6 and will give you positive 1 in the middle? So that should be, what, positive 3 and negative 2. So in the middle, I'm going to rewrite positive 3x minus 2x. And then we're going to factor by grouping. So then first group, I can take out an x. Second group, that's negative 2x, so I can take out a negative 1. So when I take out the first x, then that's 2x plus 3 is left. If I take out negative 1, 2x plus 3 is left. So then 2x plus 3 is one of my parentheses. And then the stuff outside as your GCFs is your second parenthesis. And it doesn't matter which order you put those in. You can put the x minus 1 first and 2x plus 3 second. Okay? So now I've factored everything that I could. Now let's look for our restrictions. So we look at just the denominators, because remember it was okay to have a 0 in the numerator. So I would set each of these pieces not equal to 0. So if I set 3x not equal to 0, that means that one of my restriction is that x cannot be 0. If you set this not equal to 0, that would mean positive 3 would also be a restriction. If you set this not equal to 0, you would minus 3 divide by 2, so that'd be negative 3 halves. And then if you set this not equal to 0, you would get positive 1. Okay, so those are your 4 restrictions here. Step 3, let's start canceling. So if I just do straight up and down first, I can get rid of this x with this outside x here. If you look straight up and down here, you can't cancel anything. On the diagonal, however, we can cancel the x minus 3's. And this diagonal, nothing. Okay, so then my answer is going to be what's left over. So on top, you have to have a placeholder on top, so that would be 1 in this case. Then there's a 3 in front, and then 2x plus 3, and x minus 1. Again, the order of those two parentheses doesn't matter, and we want to put whatever's outside the parenthesis in front. So there's your answer with your restrictions. Okay? So go ahead and pause this and try part C. So see if you can do part C. Okay, so first you should have factored everything that you can factor. So this will be 4x squared. I'm going to break this up because this means that you have x plus 2 twice. Then multiplied. The top here, you should have gotten x plus 2 and x plus 1 as your two parentheses. And then the bottom here is just going to be 2x squared because it's a monomial. So then restrictions. Hopefully you got x cannot equal negative 2 or 0. And the order of your restrictions is not a big deal. I'm just going in order from left to right. Okay, so negative 2 showed up twice, but you only need to write it once. All right, now let's start getting into some canceling. It's always my favorite part. I feel like I'm actually getting somewhere if I can cross something off. So, now on this diagonal, you can only cancel one on each place. So I can only cancel this x plus 2 with just one of those x plus 2's. Okay? On this diagonal, 2 divides into 4 twice, so that'll become 1, and that becomes a 2. And then the x squareds are completely gone. They completely cancel each other out. So then my answer is going to be 2 parentheses x plus 1 all over x plus 2. Okay? And again, you can't cancel this outside 2 with this inside 2 here. So there's your answer and your restriction. So good job. All right. Last one here. So go ahead and pause and try this one if you haven't already. Okay, so on this one, we again still want to factor everything that we can. I'm going to go ahead and make this one a fraction, so I'm just going to put this all over 1. So hopefully you realize that that's something you need to do. So then the x stays the same. On the bottom, you could take out a GCF of 2. So then you have x plus 2 in parentheses. Here you can take out an x, and then you have an x plus 2 left, and then that's all over 1. Okay, so restrictions. X cannot equal, now this 2 in front without an x variable does not give you a restriction, because you would set 2 not equal to 0, which doesn't produce anything because there's no variable. So you only set the monomial not equal to 0 if it has a variable. So if you set that, then negative 2 is a restriction. And then this 1, again, with no variable, does not create a restriction because this denominator will always be 1. It will never be 0. Okay, so then that part's done. Now let's start canceling some things off. Really the only thing that you should have been able to cancel is on the diagonal the x plus 2. Since these x's are on the same level, you cannot cancel them. So then x times x, you have x squared on top, 2 times 1, you have 2 on the bottom. So there's your answer and your restrictions. All right, now the last thing we need to talk about is division of rational expressions. So steps are very similar. Okay, so first, factor again. Factor, factor, factor everything that you can. Second, find the restrictions on all the denominators after you've factored, just like normal. Now, since it's division, you can't cancel anything until you have a multiplication problem. So then remember, division is the same as multiplying by the reciprocal of the second term. Okay, so then we're going to multiply by the reciprocal of the second term, so you have to flip the second term and then change the division sign to multiply. Now, once you do that, before you start canceling, you need to state any new restrictions on the new denominator. Because once you switch it, then you're going to have a new denominator, and so you will need to check to see if it adds any new restrictions. Then we get to cancel, same way we did before with multiplication, and then write what's left over as your final answer. Okay, so if you need to pause before I go on to example 3, go ahead so that you can copy those down. Okay, so example 3. Again, it could say simplify the expression, or it could say what it says here, perform the indicated operation. So first, let's factor everything that we can factor. So x plus 3 will be good. I'll parenthesize that one. Over 4 divided by 2 parentheses x plus 3. And you take out a GCF of 2 all over 3. Okay, restrictions. Now, as it is right now, since there are no variables in the denominator, there are no restrictions, which happens. If there's no variable in the denominator and you just have numbers, well, this fraction will never have a 0 in the denominator because it has a 4 in the denominator. It's constant. Same here. This fraction won't have any restrictions because there's always a 3 in the denominator, as it is right now. Okay, so find all the restrictions on the denominator. So far, we're done. Okay, but I'm not going to write none yet in case I do get some. Next, multiply by the reciprocal of the second one. So that means the first guy stays the same. Then this becomes multiply by the reciprocal, which is going to be 3 over 2 times x plus 3. Then before you cancel, state any new restrictions. Now that we flipped this, we have a new denominator. So this does create a restriction. So if you set x plus 3 not equal to 0, then one of your restrictions is that x cannot equal negative 3. Okay, then we can start canceling. So you can only cancel when there's a multiplication sign. So x plus 3's are gone. 2 and 4 are on the same level, so you cannot cancel anything with that. So then my answer should be 3 on top, and then 4 times 2 is 8. So then my final answer is 3/8 with one restriction. Okay? All right. Go ahead and pause and try sections B and C, and then we'll come back and wrap up these notes. Okay. So I went ahead and for part B, I have factored everything that I could factor, and I still left a division at this point so I could do restrictions here. So restrictions before I flip are going to be positive 2 and positive 1. So x cannot equal 2 or 1. Then I went ahead and flipped it, so then my new denominator would yield a positive 1 again as a restriction, which I already have that, so I don't need to rewrite it. Okay? Now let's start canceling, so I can do the x minus 2's. I can also do on the same fraction here the x minus 1's. And so then hopefully you had your answer is going to be x over 2 with restrictions that x cannot equal 2 and it cannot equal 1. Okay, here I went and factored everything that I could factor. This one you had to do AC method to get those. So before flipping, my restrictions, x cannot equal positive 1 and 0. Positive 1 from this parenthesis, 0 from this. Then I go ahead and multiply by the reciprocal, which brings this to the denominator. So new restriction then would be both positive and negative 1. So I'll just put plus minus. You can write them as separate if you would like. So you have 3 restrictions on your input or your domain. Okay, let's see. What can we cancel? X plus 1. You have a 12 and a 6 here, so 6 goes into this 12 twice. And the x minus 1's are on the same level, so you cannot cross those out. So then my answer, what's left on top, is 2x plus 1 with an x in front of that because we had an x left here. And then on bottom, we now have a 2 in front, and then I have x minus 1 squared. I guess if you want to write them out separate, you can, x minus 1, x minus 1. And that's your final answer. Okay. So your homework is going to be a worksheet, so use your time to work on that, and then you can check it with my answer key. The answer key is also posted on D2L, and then you'll have a quiz on this next time we meet.